Hey, what's happening? Today we're going to go over a RAG architecture that uses your data on your local computer or a file server, or even from your company websites. It will then take all that information, put it onto an edge server that will then embed the information to a Pinecone database, store the original contents in a Mongo database, and at the end we're going to build an application to utilize this. It should be good times. Okay, so we're going to kind of go through the RAG architecture. It first starts off with this text extraction node. This allows you to pull the information off local systems or file servers. You can run this manually, or you can start it on a scheduler that will scan your systems by whatever time interval you give it. It will import the information. It first checks to see if it's excluded. So if you do have information on your computer that you do not want to be part of this, you can exclude it. So if the file or the directory is excluded, it will go ahead and skip it and move on to the next one. If it is okay, the system will also check for PII, so Personally Identifiable Information. So as you're going through this, if it finds some of the patterns it's told to do, it will flag it and see, did you give an override to the PII? If you did, it will store it. If not, it rejects it, stores it in the PII, and lets you know that, hey, this system or this file has PII in it. So this way you can remove the PII from the file, approve the PII, or just exclude the file itself from being part of the system. And then actually it just stores it on your edge server. So basically, this is something that's on your edge server. This way it doesn't bog down your local system when it's starting to chunk through and process its information. The other thing I have is a web text extraction node that will just do basically a web crawl and just crawl through all your information for text and PDF files, grab all the links from everything, and just keep searching it. It will only search the domain that you give it. If there are links to other domains, it will skip it. It also does clean it up. So it does read in most of the data, the text itself, from tags, and then stores that on your edge server. From your edge server, we do loop through all the different text files that are created. It does clean up a lot of it. So the information we store in the vector database, we remove a lot of stop words, the, and so on. Also numbers. So I do pull out a lot of numbers because it makes the vector database very sparse. So we're going to clean up some of that stuff. So there's a lot of cleanup functions there. At the end, I also store the original content in a Mongo database because we want to be able to do other things to that data. So I built a little sample app that allows you to type in a prompt. We embed that information, send it over to Pinecone, get back to similarities. And then at the end, I take the information from that, the similarities that came back. Based on those IDs, I go get the content from the Mongo database, pull that in with the content and the prompt. That gets sent over to ChatGPT, and you get your answers. So good stuff. I'm going to try to walk through the code a little bit, but you will love it, hopefully. All right, so we're going to do a quick walkthrough of the text extraction node right here. So we're going to kind of just walk through this one really fast just to show you a couple of nuances. The config file, config.json, is kind of where most of your stuff is going to be at, your logic, so it's not hard-coded into the app. Your pattern matching, if you do want to pick up, let's say, login credentials. Oh, confidential words. Those are always good ones. So you can actually just put them up here, and then it will pick it up. So your PII, when it scans through all the text, it will then reject it. So good one to look at what kind of stuff it's picking up for PII. It has your input directory of where my files are looking at. This is an array, so if you're on a system that you want to scan multiple directories, that's where you put it in here just by putting multiples in the array. Your edge server information, this is where your output is going to go to your edge server, so a local file share or something like that would go there. Your hash files. Hash files are important because as it reads through the information and converts it to text, it will make a hash of the file. So as it's scheduled to run through hourly, daily, or whatever it is, if the file hasn't changed, it will just ignore it. If the file did get updated or modified, the hash would change. It will then notice that it's different and pick it up. It will also pick up new files the same way. And then the scheduler, you set up your time on how much you want to do it. It's just a super basic scheduler just to kind of walk through the demo of this. Anything in your exclusion list is an array, so anything you want to say don't look here, you throw in your exclusions. Your hashes of how everything works. This is your PII list. This means that you okayed the PII to be texified. So if you do read through it and it's a false positive, then you can just allow it to go through the list. Your requirements doc, these are all the different things that we're bringing in. I do link over to a file on GitHub that just has a utility Git. Instead of me adding it into the directory and across multiple systems, I just share it through here. And the scheduler, this is just a basic scheduler. So the app itself, very basic app. One of the cool things about the app itself is it does have data loaders. So I do use a data loader. So if you do want to pick up different, more files, right now I'm reading in this many in the data loaders. If you do want to pick up a different data type, you would just add in the information here, put in your loader, and do it. So it's pretty much plug and play on this. The system will automatically pick up the loader, find the extension, call out to using the interface, calling out to the system, find out what it is, and pull the loader in. So pretty good plug and play on this system. So as you do have issues or anything that happens, you can go to the loaders and make everything more detailed. And the app itself, pretty basic. I think the data loaders is the big one you'll definitely want to understand because that's basically what makes the whole system function. All right, so we're going to do a quick walkthrough of this. I am going to add a bunch of PII stuff just so you can see, you know, sometimes you can make this a little check for too much stuff. Delete some of these duplicates. All right, go ahead and save that. We'll run this now. And you will see that it picked up nothing. I need to delete the file hashes from the previous run. This will assume it's never run before because there's no hashes and it should be perfect. There you go. So doing this process here, it will actually say that it did convert 5 different files and did find 4 files with 6 different instances of PII. And what that kind of looks like is this. Through each one of these, this one was flagged for medical record. This one was flagged. This one was flagged for sensitivity. So if you did want one of these to go through saying that, say I want this one to go ahead and go through, you can just grab this directory, this name. We're going to go ahead and save this. And if we run this again, it's not going to pick up any of the file system ones that have hash, but it will pick up one new one. And it just did it, converted it over. So if you actually look at the log itself, you can actually see, it's probably down at the way at the bottom. It did pick up the previous. You can actually see where it did detect PII in each file. And this one did say that it was okay. So good stuff. All right, so very similar to the text extractor node, the web extraction node will do basically the same. Starts through, grabs your pages from your domain, grabs all the links, and just keeps going through and processing the information. This one will process HTML and PDF files. You later can add in more. You just have to change the data loaders. This one has the config just like the previous one, text PII. This one also does the reading in of the files. Oh, requirements. Requirements, this one actually just does the packages here. This is just like a PII process, but I'm just using Git just so I don't publish them to a public area. And the app itself, super simple. You just kind of put in your domain name that you want to process. Anything in this domain, it will loop through as far as you tell it to, and it will pull in all HTML, PDFs, and HTML files. I think right here it does do some processing. Oh, here's the actual data elements it's reading in. You may want to read in divs or something else. You can start putting that into PDFs. This is where you would actually modify some of it if you wanted to do more of data. It's like doc files or something. So one thing I did add is a throttle. This allows you to make a lot of calls for a long period of time, but just not get blocked because you're not hammering the website on information. Yeah, so I think that's it. Very basic web crawler. All right, so this is chunking, chunk extraction node. This is the one that runs on your edge server that will take the text files outputted from the text extraction node or the web text extraction node. Use that as input to create and clean out the information and put it into chunks that we're able to use in our vector database and Mongo. These are external systems that you will need to have set up during this demo. OpenAI for our embeddings in ChatGPT. We're going to use the vector database Pinecone, and we're going to use MongoDB for our content. All right, let's see how this works. First, you need to go ahead and set up an account in Pinecone. In this example is our vector database. So sign up or log in. In this example, I'm just using the serverless one compared to the default, just for ease of use. I'm going to create an index. We're going to call this, and your dimensions are set up by, and I'm going to go ahead and bring up OpenAI. I brought it up here for your embeddings. So whatever embedding model you use, in our case, we're going to be using OpenAI's embedding model. The output dimensions is 1536. So your output dimensions need to match from your embeddings to your vector database. So 1536 is where we're at. So we're going to go ahead and put this at 1536. And we're good to go. We're going to go with serverless. We'll pop this in. We'll go to Oregon. And we're going to go ahead and create. While that's creating, we can go over and go into Mongo. And this is Mongo Atlas. So it's hosted at Mongo itself. You can try it for free or sign in. All right, so after signing into Mongo, we're going to go ahead and create a cluster. We're going to go with serverless. We'll store it there. We'll go to Oregon. Serverless, I don't want any backups, again, just for demo purposes. And we're just going to call this Blades of Grass demo. This just gives us our cluster name so we can log in. And we're going to go ahead and create. All right, so while that's creating, we're going to go back to Pinecone. Does look like everything's in there. You will need to set up some API keys and some login information because you're going to need some of this information to log in through your environment variables. So we should be good to go here. All right, looks like the cluster is created. One thing you want to do is just grab the connection string. Just click on connect. Go to VS Code. And just copy over this information. This will go into your environment variable login information. So at this point, we're all good to go on that. All right, so one last thing you need is OpenAI. So inside OpenAI, you will need to log in and have a Plus account because you will need to create API keys. So this is creating your OpenAI key that will be needed for embedding and the ChatGPT side of it. You create them on the API keys on OpenAI. All right, so now that we all have that done, let me go ahead and minimize. And going back into chunking, this is where we're at right now, is on the edge server. Going to the config file, we have the Blades of Grass demo. The namespace is kind of important. It allows you to store it in a namespace. So if I store it in public, and I have all my other nodes storing information in public, everything will be accessible to the public. But I may have my own private namespace that I want to be able to query on. That way I can put the namespace in here to how I want it to be, that I can actually store all my file systems in there, because the ability to query all your files and ask questions of your entire computer is super powerful. Your chunk size, I have at 1800 with an extension of 248. This allows me to put my chunks into small sizes for the vector database, but my extension allows me to not just cut off at 1800, but finish the sentence, so it makes it more understandable. The README, or oh yeah, let's go to requirements. The requirements, very basic requirements of what we need. Those are your information for Mongo, OpenAI, and Pinecone. Your schedule is the same. All right, so your app, the chunking app, chunk extraction node. This will go through all your information that you need to grab all the text and chunk it up for the system. Very basic stuff. You can walk through it, but it's pretty straightforward. The only thing that you have to, let's see if there's anything on here that's gotcha. I think most of it's pretty simple. Oh yeah, I will say this though. One thing I did run into, because my Mongo database is stored in a document. So there's one document with multiple chunks, but my vector database was individual chunks. The problem came up with is that if I modified a document that was, let's say, 20 pages long, I modified it to 8, which would be perfectly fine on the Mongo one because it's in a single document. The vector database being individual chunks, I started having orphans on. So this will actually go through the system and analyze to make sure that you don't have orphan chunks inside your vector database, and it synchronizes with your other one. So that was a that was some fun figuring that problem out. But other than that, it's pretty straightforward. Takes your information, embeds it, stores in there, and you're good to go. So pretty straightforward of a system, but super powerful. All right, for a quick demo, I'm going to go ahead and bring up where the files are. The files are right where the output is. If you go to the config, and you will see it's going to be bringing in, looks like 6 files. So we're going to go ahead, and these should be empty when they're done. Let me move that to the side, and we're going to go ahead and run it. All right, so that looks like that ran. You'll see that the inserted into Mongo, knowing it's a new one, if it would have happened to been an update, it would have said upserted. Pinecone is an upsert on everything. So that seems to work. They all they ran. Let me go ahead and files are all gone. So that's a good sign. Let me go ahead and check Pinecone real quick. All right, so going through Pinecone, this was the Blades of Grass demo, and you'll see that it did store 35 vectors. Let's make sure that matches. And you did have 35 chunks. So that's a good thing that your individual chunks got stored in Pinecone correctly. To see what the data looks like, the sourcing, parent IDs, everything's matched up. And to understand how that parent ID works, it's kind of like this, right? So your IDs will match up on Pinecone to the chunk ID inside of Mongo. The chunk number will match up with the chunk number, and then the ID inside of Mongo will actually be the parent ID inside of Pinecone. All right, so inside of Mongo, we'll go over and click on Database, scan down to your cluster that we call Blades of Grass Demo. We're going to browse the collections. We do see the Demo 24, and you'll see that we should have 6 documents. Let's see, 6 documents. So this does tell you a good sign that there's 6 documents with 35 chunks inside the documents, and we did have the 35 chunks inside of the other one. So let me go back there. And then you'll see if you look at these will actually have the different chunks of data inside of there, so you can actually view all the information that you need. So Good stuff. On to the next part. All right, so now we're actually to the application that implements all the hard work for your RAG architecture. We're going to go ahead and take in a prompt, send that over to ChatGPT to do embeddings. We're going to take that embeddings, send them over to the vector database Pinecone, get back the results. We're going to query Mongo based on the chunks we got back, the IDs, just to get the full contact. Because remember earlier, we removed a lot of stop words and numbers to make things go quicker and better results. So we need to get that information back. We're going to take those results with the question all in text, send that over to ChatGPT, and get our results. So here we go. The command one is a command prompt, just like it sounds like. You just send it in whatever you want in your vectors. Super simple. We're just going to go ahead and run it. You can walk through the code. Really doesn't do much. New things, Python, and this we're going to use the command. We'll say who is Michael Sulio. This will give you some basic displays of all the information we're using. And there you go. If you ask that to ChatGPT, it may not know who I am, but it sure should. But since I'm hitting my RAG system, it does know. I'm going to go ahead and run the... Oh, and it does everything, right? On the next one, I'll try something else. So on the app, this one right here, let me close it down. This runs at the very bottom, Gradio. So it actually will spin up a kind of an application. So I'm going to go ahead and terminal, Python app, and this should pop into a terminal. And there you go. Blades of Grass, just basic assistant. We're going to use 24. This drop down, if we had multiple namespaces like we talked about earlier, we can select them. It gives it a basic system prompt, and then I can just say, how can I live to be 100? That just happened to be one of the documents I put in there for a sample. All right, so there you go. Different lifestyles, kind of what to do. Reduce caffeine. God, how can I get through the day? Different all kinds of different stuff that it gives you. The good part about this app one that I did was I actually put the actual chunks in here that I received back and then the scoring. So I can analyze. This was a lot of my Q&A process, because even though the RAG system that we went through, you can build out, but 90% of your time in this process will be going through and reading all your different chunks to make sure that the output match. So this will tell you all the information, the sources, the chunk numbers, everything you need to do to start verifying your results. All right. I hope you enjoyed this. Way longer than I wanted it to be, but it is complicated. So hopefully you did enjoy it. Have a great day.